Throwback Thursday, the 11th of March. Students will be able to use and understand functions trig functions, I should say, for right triangles. Use and understand trig functions for right triangles. So we're going to learn about sine, cosine, and tangent. You might have heard of this class that we have offered at the high school called pre-calc/trig, trigonometry, okay? It is a math class. It would be a few years down the road after geometry. Now, this is kind of like an introduction, in a sense, at the most, okay? So we're not going to go incredibly in-depth into trigonometry by any means. We are just grazing past trig functions realistically, okay? There's so much more to them. We are just covering what applies to right triangles today. So there's certain parts about trig functions that apply to right triangles, and we're going to cover some of that. Not even all of what applies to right triangles. Some. These trig functions are called sine, cosine, and tangent. Now, we've learned about different functions in Algebra 1. You learned about linear functions, which made lines. Quadratic functions, which made the parabola, the U. Okay? And other functions like that. The absolute value function makes a V. Different things. Sine, cosine, and tangent are going to be other functions. They make different graphs as well, but we aren't going to be worrying about their graphs. We're going to be worrying about how we use them as an operation, similar to how you would add, multiply, divide, subtract, you name it. Take the absolute value, take the square, take the square root, those kind of things. We're going to view it as another operation, taking the sine, cosine, or tangent of an angle. So it's an operation on an angle. It's a function of an angle. Emphasizing. So, we have this right triangle here. We know it's a right triangle because it has the right angle. The points are marked A, B, and C. They're capital letters because they are points. Now, oftentimes, we'll call the side across from it the lowercase version of that. De nada. Also, that's saying you're welcome for taking it instead of gracias. It was a double joke. Yes, it was a double joke. All right, so we could call this like a lowercase a lowercase b, a lowercase c. Don't write that down, though. I just want to let you know we can call those lowercase ones opposite it. Now, in the right triangle, Kenny, put it away. We have a hypotenuse. Where is our hypotenuse right now? Across from C. It's segment AB. That's our hypotenuse. What are the other two sides? Not necessarily short leg and long leg. Do we know one's shorter than the other? Longer than the other? No, we had short leg and long leg last section when we had 30, 60, 90 triangle, right? Short leg goes across from 30, long leg goes across from 60. But we know they're legs, right? Okay. And when we had 30, 60, 90 triangles, we were able to get specific and say, this is our short leg, this is our long leg. And we were able to differentiate or separate the two of them. Right now, do we have a really good way to separate the two of them to differentiate which leg we're talking about if we say the leg? No. No, not without a measurement of saying, oh, this leg or this leg, the leg that's 5 or the leg that's 7, but we don't know the measurements. You can say the leg that goes from C to A, but that's pretty wordy, isn't it? And then you have to remember multiple letters, all this stuff. So here's what we're going to do. I can call this leg over here on the left-hand side the leg opposite angle what? Angle A. This leg is opposite angle A. It's across from angle A. It is not touching angle A. Could it be opposite angle B? No, it's touching angle B. Could it be opposite angle C? No, it's touching angle C. It's the leg opposite angle A. So if I said, hey, the leg opposite angle A, would everyone know what leg we're talking about? Yeah. Now, what?
You have to be like opposite something different every time.
Yeah. So I could also say, what's this leg on the bottom? The leg
opposite B.
Leg opposite angle B, and I could put OPP for opposite if I wanted. Leg opposite angle B. Write these down.
Which suit is better, Mr. Crawford?
I'm not sure. I might. I'll actually probably lean the ham and potato maybe a little bit.
It's okay.
But they were both good. I mean, there's a reason I got one of each.
The reason
All right.
why you take all the food.
There you go. My long division, is that what I heard?
Wrong decision.
My long division? Okay.
Wrong decision.
Yep. My insurrection. Now, I could also say that this leg over here is a leg adjacent. Wait, what does adjacent mean?
Opposite. No, they're touching.
Touching, next to. Adjacent means they're touching or next to. So this is a leg adjacent to what angle? On the left-hand side. This leg is adjacent to what angle? Well, it's kind of adjacent to two of them, right? Mm-hmm. But if I say it's a leg adjacent to angle C, what is this leg also adjacent to angle C?
B.
So does that help us at all? No, what would be a way I could help then? Say leg adjacent to angle B. How many legs are adjacent or touching angle B?
Not that one.
How many legs are adjacent or touching angle B?
Oh, one.
One. Because what's the other side touching angle B?
Hypotenuse.
The hypotenuse. So how many legs are adjacent to angle B? One. What could I call this one over here then?
Leg adjacent to angle A.
Very good. The leg adjacent, I could shorten adjacent to ADJ. Leg adjacent to angle A. Once again, I could also say angle C, but that wouldn't help us at all. Leg adjacent to angle C, we might as well just say legs, because they're both adjacent to the right angle. So we can call it the leg opposite an angle or the leg adjacent to an angle. Make sure you have all these written in here. That's what a student is deciding to call me because I love peanut butter. No, it's an even day today. All right. Now, yeah, I looked at my watch. That's the joke. It's a double joke. Gosh, these jokes are getting us. Man. All right. So I may or may not have been watching a video that my TA showed me yesterday of like Party Rock Anthem by LMFAO. So a pull off of what Ray was saying there, LMAO. And where in the Party Rock Anthem video, they're all dancing in the street, whatnot, and it's just put to other songs that are at the same beats per minute. It's a pretty interesting video. Anyway, so if you have 3 minutes of your life that you want to waste, it's not a bad way. It's not a terrible way to waste them. Oh, it's definitely a waste.
Have you ever heard people when they mixed in the female and the male version of the song, it just turns out really creepy?
No.
It's really creepy.
Interesting. If I want to waste my life that way, I'll let you know. Because I wasted my life another way yesterday. I mean, a lot of those things, I'm just wasting time. Being honest. All right. Hey, if I have in this triangle, angle A, what could I label this side over here as?
Leg opposite of angle A.
Very good. The leg opposite angle A. Okay, I could also call this one the hypotenuse. What can I call that other side?
Leg touching angle A.
What's our word for touching?
Adjacent.
Adjacent. Leg adjacent to angle A. So I can label all three sides in reference to my angle. What do I mean by in reference to my angle? What does that mean in reference to my angle? Seth?
I have a question. Why does your angle A look like that way?
I don't know. What do I mean when I say I'm labeling these legs in reference to my angle? Yeah, Kenny. Starting from angle A. Based upon this. Starting from this. In reference to means you're referring to that. Basing it upon that.
What is that?
SOHCAHTOA. Now, SOHCAHTOA, that's how you pronounce that, SOHCAHTOA, SOHCAHTOA, is a theorem we're going to use, and it's actually an acronym. SOHCAHTOA is an acronym. Yes, it sounds like Sacagawea. All right, so I have a student every year write down Sacagawea instead. Well, they normally spell it wrong, but anyway. SOHCAHTOA is an acronym to help us remember. are three trig functions, which are actually ratios. Ratios, remember, is a comparison of numbers. This divided by this. Flutes to trumpets. Wins to losses.
Can you please say that?
Kills to deaths in a game. Yes?
How do you know that they spelled Sacagawea wrong?
You looked it up.
Because it's obviously very wrong when they spell it.
But how can you say how they spelled it? They didn't write or speak English. Just saying.
Okay.
You know I'm right.
For the accepted spelling, it is not matching to that.
There you go.
Okay. Now, sine of angle A. This is how you pronounce this. You pronounce it as sine, just like you're signing something, or you see a sign on the street. Okay. Shh. Sine of angle A would be equal to the opposite. Excuse me, let me write that. Let me change that. Instead of opposite, I'm going to write it would be equal to the leg opposite angle A. Oh my goodness. Change it one more time. I'm sorry, guys. My apologies. Sine of angle A, we can actually abbreviate it first into the first three letters. We are not going to call it sin. I'm serious.
Sin.
We're not going to call it sin. It is a sin to say sin. Okay? Sine of angle A is equal to the leg opposite angle A over the hypotenuse.
Wow.
That's why you said that
What did I say to you?
hallway. You mean a sin and you go, Elizabeth, it's a sin to say sin. You said it to me yesterday. I don't remember who said that.
Yes.
Now I know.
So it's the leg opposite angle A over the hypotenuse. You would take the measure of the leg opposite of angle A over the hypotenuse, and you would have that as your ratio for sine of angle A. The next one is cosine of angle A. Cosine, like somebody's cosigning for a loan. Cosine of angle A, you can abbreviate this as COS. We are not going to say cos. The only time you should be saying cos in here is if you're starting to say my last name. Okay? This is cosine of angle A.
Mr. Cross Dog.
Cosine of angle A is the leg adjacent angle A over the hypotenuse. So you take the measure of the leg adjacent to angle A and divide it by the hypotenuse measure.
You said sin a lot today, so you were saying.
Tangent of angle A.
You're gonna have to go to the section.
Tangent of angle A is going to be pronounced spelled T-A-N. It's still pronounced tangent of angle A. It is too cloudy outside to get a good tan anyway right now. So, we would take the leg opposite angle A divided by the leg adjacent to angle A. Now guys, these are abbreviations. So once again, an abbreviation, you don't say the abbreviation. Like you don't say like TAN. Just like you don't say, when you're saying my name, you don't say Mur. You say Mr. Because that's what it's abbreviating. Okay? You don't say Mur. You say Mr. Okay? Classic.
Your name is now Mercostle.
Yes, yes.
No, it's Mercase.
Okay? And there are plenty of other scenarios. We don't just say the abbreviation. You say out the word. The abbreviation is just to save time writing and save space. Okay? Sus.
Indeed. Pink is sus.
All right. Now we have these.
Very pants sus.
So SOH is going to stand. It's an abbreviation. This is an abbreviation, or it's going to be an acronym. it is sine is opposite over hypotenuse.
I hate spelling sine like this.
That's too bad.
Wait, did you say hypotenuse?
If I did, I said it incorrectly. Hypotenuse.
Hypotenuse.
Sine opposite hypotenuse. SOH. So, sine, guys, sine is equals opposite over divided by hypotenuse. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So, SOH. Ka. So, ka-toa. So, katoa. Cosine is adjacent over what? Hypotenuse. The C and cosine, the A and adjacent, and the H and hypotenuse are abbreviated, or used as acronyms, I should say. Cosine is adjacent over hypotenuse. Can anyone tell me what they think TOA ends up being? Kenny?
Tangent
Yep.
over.
Tangent is?
Yeah.
What was our O we saw earlier?
Opposite.
Opposite. So thank you for not blurting. Keep going, Kenny.
A. Oh, over what?
Yep, over.
Over A. Hypotenuse. No, A.
Over angle.
So what's the A? Adjacent.
Add adjacent, dude. Add.
Adjective.
So tangent, opposite, and adjacent are where we pull the T, O, and A from.
Opposite.
So all of these is blank over blank. They're all blank is blank over blank. They all follow that pattern. Something over something. Something is something over something. In this case, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now this abbreviation exists, SOHCAHTOA exists, for the pure reason to help you guys remember it. Only reason that it exists is to help people remember what it is, how to do it. So every three letters, S, C, and T, start the next trig function, start the next trig ratio, sine, cosine, tangent.
O is the only one that
Then what sine is follows. OH, opposite hypotenuse, opposite over hypotenuse. Kenny?
May I use the restroom?
Yes, good luck.
I'm gonna go take a swim.
I hope you don't.
Need you refreshed.
All right. So, we're going to practice finding the sine of angle B, the cosine of angle B, and the tangent of angle B. So what angle are we going in reference to this time?
B.
B. So here's what I'm going to do. I'm going to circle angle B to know that we're going from there. And now I need to label my sides. So would 40 be my opposite leg, adjacent leg, or the hypotenuse? Adjacent. So I'm going to say that's the ADJ. That's the adjacent. Okay. What would 75 be? The opposite or the hypotenuse? Opposite. OPP. And what would that leave 85 to be? The hypotenuse. So for angle B, we have the adjacent leg is 40, the opposite leg is 75, and the hypotenuse is 85. So sine, that's our SOH, sine of angle B is equal to blank over blank. What's it say? The blank over the blank. What does SO stand for? Sine is? Opposite over hypotenuse. So what is the opposite measure? 75 over divided by, what is the hypotenuse measure? 85. Sine of angle B is equal to this ratio. This number over this number. Now can we reduce this ratio? Yeah, what is 75 divided by 85? Well, what goes into both numbers? 5. And 5 goes into both numbers. It goes into 75 how many times? 15. And it goes into 85?
16.
17.
17 times. So sine of angle B is 15 over 17. I want you guys to try and find cosine of angle B and tangent of angle B. Raise your hand when you have it or have questions. So for cosine of angle B, it's going to be blank over blank. The
40 over 85.
Yeah, it's the adjacent over the hypotenuse, which is 40 over 85. 5 goes into both of those to become what over what?
17.
8 over 17. And then tangent of angle B.
75 over 40.
Yeah, 75 over 40. That should be our
15 over 8.
opposite over adjacent, which becomes 15 over 8. Questions on sine, cosine, tangent of angle B. Now, on letter B, what's it asking us to do?
Find it from-
Do the same thing for angle A. So what do we need to go back to our picture and do? For angle B. So we need to erase what we have right now because is this still going to be the adjacent side on the left? No. Is it still the opposite on the right, on the bottom? No. Does the hypotenuse stay the same though? Yeah. So what is 40 now? Is it not? It's no longer the adjacent. It's the opposite. Very good, Dylan. And that makes 75 the what? Adjacent. So I want you guys to find the sine, cosine, and tangent of angle A. When you have it or have questions, raise your hand. So sine of angle A was equal to blank over blank to start. Thank you. Very good, Presley. 40 over 85, which then reduced to 8 over 17. What do we notice about the sine of angle A compared to something for angle B? Did anyone notice? Sine of angle A is what compared to something of angle B? It's the same as cosine of angle B, isn't it? Well, why do we think that is? The sine of angle A is the opposite over the hypotenuse, right? But the opposite for angle A was what for angle B? The opposite for angle A is the same as the what for angle B? Adjacent. So when cosine did adjacent over hypotenuse, the hypotenuse stayed the same, 85 and 85. But what was adjacent for one is opposite for the other. So what should the cosine of angle A be the same as? What should the cosine of angle A be the same as? Should it be the same as the sine for angle B? Because cosine of angle A will be the opposite, which is... the cosine of angle A will be the adjacent. I said opposite. Adjacent, which is the same as the opposite from angle B. And they're both dealing with the same hypotenuse, so that part doesn't change. So we end up having 75 over 85, which is just equal to 15 over 17. And then for tangent of angle A, we had 40 over 75. What do we notice about this tangent compared to the other tangent? You can't even see that.
The exact, the reciprocal.
Very good. The reciprocal of it, okay? The tangent of it is the reciprocal of the tangent of angle B. The reason why is because it's opposite over adjacent. Well, the opposite and adjacent, what did they do between angle A and angle B when we switched from angle A to angle B?
They switched.
They switched. So these two are just going to switch places as well. Neat. Any questions on that? All right. We're going to go through some rules for using trig ratios. I need everyone to have a calculator. Scientific of some sort. So whether that's your iPhone one, I can work with that. Or scientific calculator of mine. Grab a calculator. Calc 84 on your phone app would be good as well. There needs to be some sort of scientific functions on it.
I have a calculator.
Yeah, I got that.
Yeah. Honestly, the iPhone calculator is inferior, and I say this as someone owning an iPhone. The iPhone calculator is very inferior.
Android.
Android has a much better calculator. It's not even close. Android has a true scientific calculator. Apple has a very calculator.
I'm
What?
superior.
I don't know either, honestly. It's actually one of my big gripes with Apple on their phones. That's probably the thing I dislike the most about the Apple phone is the calculator, but I'm also a nerd. So,
I am superior. I
so
have Android.
what we're going to do, okay, is I'm going to teach you how to type in and find. You might notice you have buttons on your calculator for sine, cosine, and tangent. Especially if you turn them sideways on your phone. If you turn your phone sideways, you form your orientation block.
I see that.
You see buttons for sine, cosine, tangent. They're abbreviated, aren't they? So you see SIN, COS, and TAN, which once again are not sin, cos, tan. They're sine, cosine, tangent. Now, for sine, cosine, tangent, you can type in sine of 35 degrees. You could type that into your calculator, and it gives you a long, crazy decimal. Everyone type in sine of 35 degrees into the calculator.
Like, how do you put degrees?
Great question. So let me start off with the scientific calculators, the non-iPhone calculators. You push sine, then you push 35, you push enter.
Oh.
That's all you do.
Non-calculator.
Close the parenthesis if you want. Since we're not doing anything after, it's okay. If you're doing something after it, you want to close the parenthesis.
0.573576.
Okay, before we blur, iPhone calculators. This is how you do it. You type in 35. Then you push sine. You have to go the reverse direction.
Why?
Why not?
Because it's not a true scientific calculator. It's like an advanced 4-function calculator, honestly.
Like I said.
All right. So, you get a long string of decimals either way, correct? Okay. I want us to go to 4 decimal places. So somebody raise your hand and round it off to 4 decimal places for me. Landon.
0.5736.
Does anyone not have that? Raise your hand if you don't have that so I can fix something on your calculator. If you don't have that, that is something on your calculator that is wrong that I need to fix. It's in a different setting. Okay? Yours is right? Yours wrong? Anyone else's is wrong.
I don't know how you do that.
Next thing I want to do, cosine of 68 degrees. Type in your calculator. Raise your hand when you have it to 4 decimal places. Raise your hand when you have it to 4 decimal places. Presley, go ahead and tell me what it is to 4 decimal places. 0.3746. Can I get a second on that? Can we agree to that? Okay, good. Does anyone disagree with that?
Yeah.
Okay, what'd you get, Kenny?
Oh, wait. Hold on.
So Mr. Gossip there. Look. Yeah, Mer, I say.
No, it's
You got it, Quinn?
yeah, I got it.
You type something in wrong?
Yeah.
Happens. All right. Questions on that?
No.
Now, what that's saying, mathematically speaking, is saying, hey, we were finding sine of an angle. And we said the sine of angle A here, on this previous one, was 40 over 85, which simplified to 817. Could we turn that into a decimal?
Mm-hmm.
Yeah, we could turn that into a decimal. Okay? And so someone take 8 divided by 17 for me, please.
4705.
What was that?
4705.
No.
I got
4705? Oh, 0.4705. Okay, that makes more sense. Okay, so, let me do something real quick on my calculator. I want everyone to do the sine of 0.4705.
Wait, what?
I want everyone to do the sine of 0.4705 in their calculator and push enter.
I got it.
It's going to be not a sine of that. Sorry. Let me say that again. No, my bad. I want you to take the sine of 28 degrees. I misspoke. I want you to take the sine of 28 degrees.
4694.
695.
4695.
Okay? And we got approximately, I heard, 0.4694.
Yeah.
5.
Sorry, 0.95. Okay.
Round.
Is that extremely close to 0.4705?
No.
Are those like ridiculously close?
No.
Okay, what I did was I found out what this actual angle was. This angle is about 28 degrees, a little over. So when I had to put the sine of 28 degrees in, it said, hey, this will be what the ratio equals. And is that what the ratio was approximately? Yeah. That's what this is doing in our calculator. When we say the sine of 35 degrees, the sine of 68 degrees, it says, hey, regardless of what these actual numbers are, 85, 40, 75, whatever, the ratio of a sine of 35 degrees will always be approximately 0.5736. The ratio, when you take the cosine of 68 degree angle, is going to be approximately 0.3746. That's what that's doing. All right.
I found it exactly.
I'm going to
I know what the angle is.
28.06, 675, 751.
28.07.
Yeah, that would round up from there. All right. I'm going to assign 5 problems on this worksheet. Now, granted, the first 2 problems are like a part A, part B, part C, part D. I'll be honest about that. And that's it.
You got one problem with 18 parts.
Each test has 10 different parts.
Now, guys, on this homework real quick, the first 2 are like what we were doing on the very bottom of that previous page, where we had the ratios and we were simplifying them. Yeah. The last 2 are like those last few just random examples we were doing on our calculator, where you literally just type in your calculator and you push enter. That's it. So the last 3 problems, should they take you very long?
No.
Gosh, I really hope not.
I'm right here.
The last 3?
All right, here, Mr. Nelson, it's me. So, we're doing 1 through 5 right now.
No.
We're doing 1 through 5 right now.
Oh my goodness.
So like I said, the first 2 have some parts to it, and we need to simplify them. The last 3, 3 through 5, should be just real quick, type in your calculator, you're done. Now, real quick on number 2 here, when it has that little symbol there, the circle with the line through it, you guys see that on number 2?
Mm-hmm.
That means theta, T-H-E-T-A, theta. Theta is just saying sine of theta. Think of it as sine of angle C. Cosine of theta, cosine of angle C. Tangent of theta, tangent of angle C. Just think of it saying that, okay? Just think of it saying that. If you need to write that in, write that in. Because where is that circle with the line through it, the theta located at? Angle C. So it does operate as if it says sine, cosine, tangent of angle C.